All right, today we're going to take one more look at some of these area problems. In this first example, we're trying to do the integral from -5 to 5 of this. And at first look, most people would say, well, it's a u substitution, so my u is going to be all this kind of stuff. And then my du dx is going to be -2x. But wait a minute, we don't have an x here. And that's where most people would get stuck. And they say, I don't know what to do here. So this question is really a pre-calculus question more than anything. If you remember what the equation of a circle looks like, you have x squared plus y squared is equal to r squared. So in this case, if we use r equals 5, we would get x squared plus y squared equals 5 squared. And we could solve that for y. We subtract x squared from both sides, and then we do the square root of both sides. Square root of y squared would be absolute value of y. Absolute value of y would give us plus or minus y, but we can move the plus or minus over. So I've skipped a few steps here. But basically, if you solve for y, you get plus or minus, and then the square root of 25 minus x squared. The plus would be the top half of the circle, and the minus would be the bottom half of the circle. So basically what we have here is a circle. And because we're doing the integral from -5 to 5, we basically just want the area of the top half of the circle. And we don't need calculus for that. We know what the area of a circle is. It's just pi r squared. The r that we have is 5, so we get 25 pi for our answer. And then we say, wait a minute, we're only doing half of the circle, so we need an extra 1/2 in the front. So our final answer using pre-calculus or just basic geometry would be 25 pi over 2. So this one was more of a pre-calculus question than anything, but you did have to remember the equation for a circle in order to figure this one out. It was a little bit tricky. All right, let's go to the next question. Okay, for this question, we're just doing kind of a review. If you had something like y equals x squared minus 9, the minus 9 is kind of like the y-intercept. And if you factor it, you can see that the x-intercepts are going to be -3 and also +3. So that's where these x-intercepts are coming from. So this is just a basic parabola. Let's go ahead and connect all these dots. And it would look something like this. But for this example, in order to get any particular point, you'd have to plug in the x, and then you see what you get for y. So we're going to use our knowledge of this question right here to do the same thing, but when it's x equals instead of y equals. So let's take a look. This is almost the same thing, but instead of y equals, it's going to be x equals. So again, you could factor it, and if you let y equal -3, or if you let y equal +3, you're getting 0 for the x. So for one x value, we're getting two different y's. So of course, this is not a function, but we do need to be able to graph this in order to do some of these examples. They don't always give you the graph, and we have to know what is the right and then what is the left so that we can do the integral of the right minus the left. So a lot of these, you're going to have to be able to graph them, and it's going to be weird, but to get any particular point, you just need to plug in the y value, and then you'll get your x for your answer, and that'll give you a point. All right, let's take a look at the next example. All right, again, we need to factor out a y, and then we'll have 5 minus y times y. And so you can see that when y is 0, or when y is 5, we end up getting our y-intercepts instead of our x-intercepts. So 0 and 5 are going to be the y-intercepts. Now, because of the negative, it's going to be an upside down parabola, so it's going to point this way instead of the other way. It's going to point towards the negatives. And if you just go halfway in between, that will be the axis of symmetry. Again, you could plug in different y values, and that'll give you the x value. So if I plug in y equals 1, I'm going to get x equals 4. So when y is 1, x is 4. That gives me this point right here. I can plug in y equals 2, and that's going to give me 5 minus 2 times 2. So when y is equal to 2, x is 6. So that gives you the point, 6, 2. Because we know the axis of symmetry, we can just copy these points over. So again, today we're going to try to graph some of these x equals equations. They're very similar to the y equals. And one of the things you can always do if you don't know what's going on is just plug in some values and you'll get a bunch of points. The more points you have, the easier it will be to draw your picture. Once you have a lot of points, you can usually just connect the points, and that's what your graph is going to look like. All right, let's go to the next page. Okay, for this one, we're going to take out a y squared from both pieces. Remember, when something is squared, your graph is going to touch and then turn around. So it's going to touch at that point and then turn around. So you'll notice our graph, when we get to y equals 0, it's going to touch and turn around. And at the other spot, it's going to cross through. So when y equals 1, our graph is going to cross through the axis. So we can get these 2 points just by factoring the equation. We know y equals 1 and y equals 0 are going to be y-intercepts. Remember, usually those are x-intercepts, but everything's backwards when you have an x equals equation. Now we got to figure out this point here, and maybe this point, and maybe this point if we want to just make sure that we have everything right. So we can just plug in those y values, and then we see what we get for x. Let's plug in y equals 1/2. When I plug in y equals 1/2, I'm going to get negative 1/2 times 1/4, so that's negative 1/8. So on my x-axis, that's approximately right here. The most important thing is that it's negative. Let's plug in y equals 3/2. That's going to give me 1/2 times 9/4. So I'm getting 9/8 as my answer. So if you go to 1, that's going to be 8/8. So I'm just going 1/8 more. So that's 9/8. So this is a bit tricky, but once you have some points plotted, you can start to draw the graph. Remember, you had a square there, so it's going to touch and turn around. And this one was an odd power, so it's going to cross through. So this is kind of like pre-calculus, but we're drawing graphs for equations that are x equals. The reason why we're practicing this is because when we get these shaded regions where we have to graph the right minus the left, well, we have to know what the graphs look like. Remember, they don't always give you the graph. Sometimes you have to draw the graph. Okay, now we're going to look at some slightly different examples. These are little puzzles. So this first one says find the value of k that makes the shaded region have an area of 100. So we can move the k anywhere we want. We can move it here, we can move it there, anywhere that we want. So we're going to start by just doing the area of the shaded region. That would be the integral from 0 to k. And remember, I haven't figured out what k is yet. And we're going to do top minus bottom, so it's just going to be the square root of x minus 0. And I want this area to equal 100. So basically all I have to do is just solve this equation, and it'll tell me the answer. So let's go ahead and plug that in our graphing calculator and see what it says. We're going to want to solve this equation for k. Remember where you get solved from? It's from the F2. You can get solved. And I'm putting comma k, so k is the alpha, and then the letter k is actually right next to the 4. And then what I'm going to put here is my equation. That's this equation over here that I underlined in blue. So I need my integral to equal 100. And I'll usually write that my integral equals 100, but you'll notice I left the integral empty because I don't want to forget something. So now all I have to do is plug in my actual integral, and so my integral is just the square root of x, and it goes from 0 to k. So let's type that in right now. There's the square root of x, and my x is going to go from 0 to k. Then we'll push enter. Now it gave me some really weird value, so let me push green enter, and then I'll get my decimal approximation. You'll notice that it's only showing 4 decimals of accuracy here, but you can always go up, push enter, and then it'll give you a lot of decimals of accuracy. I prefer to truncate it, so I'm just going to put 28.231. That'll be our final answer for k. If we allow k to be 28.231, then this integral will equal 100. All right, let's move on to the next question. All right, here's a similar example where we have a k in front of our sine function. If you remember, the k is like the amplitude. If we make it a 2, it's a little bit higher. 3, it's a little bit higher. So we could even make it a 1/2, which would make it lower. So we can make the k any height we want. And there is some value of k that would make the area of this shaded region 10. And that's what we're looking for. So let's go ahead and set up the integral. For the shaded region, it's going to be the integral from 0 to pi. And we want to do top minus bottom. So our top function is going to be k times sine of x minus y equals 0. So you don't have to put minus 0. You can just put dx. So this would be the area of the shaded region. This k is kind of like a constant. So we need to find the value of k that would make that area equal to 10. So basically we just want to set this equal to 10, and we'll solve it with our graphing calculator. Let's go ahead and plug this in and see what we get. Again, we get solved from the F2, and we want to solve for k again, so I'm going to do comma k. Then I'll go back inside and put the equation. The equation is going to be that my integral is equal to 10. So I'm just going to put a basic integral and then equals 10. Then I'll go back and type in whatever the integral was supposed to be. My integral was k times sine of x, and my integral went from 0 to pi. And that's it. We'll push enter. It's telling me that k is equal to 5. So this is a pretty easy one. We don't have to round this. We just get k equals 5. So that means if our function was y is equal to 5 times sine of x, then the area of the shaded region from 0 to pi would just equal 10. All right, that's it. Let's go ahead and move to the next example. All right, so for this example, we want to find the value of k that splits the entire shaded region into two equal pieces or two equal areas. So basically, we're going to set up two integrals and set them equal to each other. The first integral is going to be the area of the blue region. So that'll be the integral from 0 to k of this function. We want it to equal the area of the orange shaded region. And it's basically going to be the same integral, it's just going to have different bounds. So the bounds of the second one would be from k to 2. So we just plug this in our graphing calculator and see what it says. Again, we want to solve an equation, so we're going to go to F2. We're going to choose solve. And we are solving for the letter k. So I'm going to do comma k. Then I'll go back inside, and I'm going to put integral equals integral. All right, you'll notice I haven't said anything about the integral yet because I don't want to make a mistake with parentheses. I don't want to miss any parentheses. So now I'm going to go to the first integral and type the integral in. It's going to be 4 minus x squared. And this one goes from 0 to k. Then I'll go to the second integral, and I'll type in the information for the second integral. It's going to be the same function, 4 minus x squared. But this one is going to go from k to 2. And that's it. I'll push enter. Now it is giving me many answers. So we need a number that lands between 0 and 2, because if you look at our graph, we need to divide the region from 0 to 2. So we need to throw away the answer that says 3.06. And we're going to keep the answer that says 0.694. You'll notice there's a third answer, k equals negative 3.7. So we want to throw away the answers that don't make sense for our problem. Our answer has to be between 0 and 2. So our answer is going to be the k equals 0.694 answer. Again, I want to push enter to get all decimals of accuracy. Let's put a box around the answer. I prefer just to truncate it, so I don't care about the 5. Remember, the AP test will accept the answer of 0.695 because that 5 rounds the 4 up. But why would you waste any time doing that? It's better just to ignore that 5 and truncate it and just leave your answer at 0.694. All right, let's go to our last example. For our last example, we want the area of region A to equal the area of region B. So we're allowed to adjust the k value. It's kind of like an x value. We can adjust it left and right as much as we want so that we can make the area of region A equal the area of region B. Now the area of region A is not changing. Let's go ahead and write the integral for that one. Remember, we got to do top minus bottom, so we're going to do 0 minus our function. And if I reduce that, I'm going to get 5 plus 4x minus x squared. And that'll be the area of the green shaded region. I want to set that equal to the area of the blue shaded region. The blue shaded region is going to go from 5 to some unknown value of k. And it's just going to be the y function. So I'm getting x squared minus 4x minus 5. And now we just need to solve this with our graphing calculator and see what we get. So again, I want to solve an equation. So I'm going to go to F2. I'm going to choose solve. And I do want to solve for the letter k. And I'm going to go back inside. I want to write integral equals integral. Then I'll go back inside and I'll type in the first integral. Then I'll go to the next integral and I'll type in the information for the next integral. So this integral is going to go from 5 to k. And then the function is just going to be x squared minus 4x minus 5. And that's it. We'll push enter. It is giving us two answers, -1 and 8. Of course, we need our k to be greater than 5. So we're going to go with k equals 8. And that's it. That's our final example.